So this is a video of my latest invention. It's a target that reacts to a practice laser and reacts almost as if it was hit by a real bullet. First shot will be a deliberate miss to show you the laser hitting, and the second shot a bullseye. Did you hear the plinking of the target? And this video will show you how and why I made my practice laser target. As customary, before we get into the video, I'll show you that for safety reasons, the gun is unloaded with no round in the chamber. And no magazine inserted. The target I made reacts to a laser trainer. The two that I use are made by Laserlyte company. The red one is the LT Pro and is inserted in the end of the barrel. And the one I'll use for the video is also made by Laserlyte and is called the LT9 and is shaped like a real bullet. Press the switch on the back of the laser, a laser beam is emitted. The laser fits into the barrel, and as you'll see, the laser is triggered when the gun's firing pin strikes the switch on the back of the laser. This causes a short burst of laser light to be emitted from the gun, as you can see here. Try firing your gun is a great way to practice your aim without the cost of real ammo. Like many people, I set up a target in my house and practiced on it. Or I would just pick a spot on the wall and aim for it. But after thousands of practice shots, it can get boring. Laserlyte company developed a target trainer that lights LEDs at the locations you hit. It's a great idea, but it didn't give me the feedback I was looking for. Then Laserlyte came out with the plinking cans, which when hit by a laser would tip over. Another great idea, but you have to pick up the cans after they were knocked over. I was looking for something more. I wanted a target that gave me the feedback as if it was hit by a real bullet. The laser target I developed gives you the audible and visual feedback of plinking a piece of steel, along with a confirmation ring of LEDs and even a hit counter. So let's get started. First I'll turn the power on, then I'll engage the plinking solenoid and reset the counter. Then I'll rack the slide. The first shot will be low and not count as a hit, so you can see where the laser hits. The next shots will be hits. The steel plate will ping and swing as it pushes back the target and as the counter advances. As you can see, I still need to add a little more grip to the bottom of the target to keep it from moving backwards. The pings you hear are from a solenoid hitting the bottom of the swinging steel plate. Next I'll put it in quiet mode. This deactivates the solenoid from hitting the plate, but retains the LED ring around the bullseye and also advances the counter. You have to be fairly accurate and hit the approximate center of the target for it to count as a hit. Here is a miss. Now I'm standing about 15 feet from the target. It's a bit difficult to aim as I'm leaning over the camera trying to keep the gun in frame. Although I haven't verified the distance at which the target will react to a laser, my assumption is that if you can see the dot, the target will react to it. So I would say easily 100 feet. And here's a few shots from a normal shooting stance. Same distance, about 15 feet. And if you want to mix it up, you can also do some very low light practice shooting. There's a potentiometer on the target that can compensate for any lighting conditions, from no light to brighter sunlight. I'll turn up the potentiometer until the target lights, then back it down a fraction of a turn till it goes off. Now I'm standing about 5 feet from the target. Now I'll turn off the solenoid, run it in quiet mode so it doesn't disturb anyone in the house. Next I'll show you how I made my laser target and how it works. It is a solid piece. All of the upper parts are made of steel. Some of it's welded, some of it's put together with nuts and bolts. The housing or the cabinet is made of aluminum. The first switch turns on power to the internal electronics and display. The second switch is what I call the quiet mode switch and activates or deactivates the solenoid plunger. The third switch is a momentary switch to reset the LED hit counter. And the fourth device is a variable 100K resistor or potentiometer that adjusts the light sensitivity of the target to accommodate for various lighting conditions. The bullseye target is a large 1-inch light-dependent resistor, or LDR, that when hit by the laser triggers a hit. The ring around the bullseye is comprised of about 24 red LEDs. The prototype I made used only one LED, but it didn't have the effect I wanted. When you hit the bullseye, the target plate will swing backwards, just as if you were hitting an actual target. This is a side view showing how it swings back and forth. The back side of the target is not finished yet. There are wires going to the light-dependent resistor, and I have run some extra wires to accommodate the addition of a tiny 1/8 inch LDR for very precise practice shooting. This would be useful if you have a rifle with a scope and you wanted to practice fire from very long distances. The LDR would fit into these two small holes on the front. The bottom has 4 foam grip pads, and as I indicated earlier, I'll need to add some more grip pads to keep the target from moving when I hit it. The power supply, as you see here, was from an old laptop. I modified it to output both 12-volt DC power to the electronics and display and 110-volt AC to power the solenoid. Taking off the bottom screws gives you access to the internal electronics. And these are some of the main components in the target. We have the control PCB, the solenoid, a 4-pole double throw relay, and a junction block. The control PCB receives the signal from the LDR, light dependent resistor, which is the bullseye on the front of the target. And when activated, it triggers a 4-pole relay to switch the solenoid, LED ring, and hit counter. The solenoid, when triggered by the relay, will hit the bottom of the steel target plate and cause the ping sound and make it swing. This is the bottom of the steel target plate that moves back and forth. I'm temporarily using a rubber band to pull the target plate back after being hit. I will probably replace this with a more reliable and longer lasting spring. This is a close-up of the target showing the 1-inch LDR or light dependent resistor and the ring of LEDs surrounding it, and that's how the LEDs look when they're activated. The target is made of 1/8 inch steel plate. I tried using a thinner steel plate, but the plinking sound wasn't as realistic. Now I'll show you how the target reacts when hit by a steady laser beam from a different laser mounted to the front of the gun. Notice that when the target is hit, the red and green LEDs on the circuit board activate. That circuit board triggers the relay, which then activates the LED ring and advances the hit counter. Now I'll turn the solenoid on, and you can see how it is activated by the relay. So that's about it. I hope you liked my laser target invention. I have about a little over $100 in parts and a lot of hours into it. I have made some upgrades from the original prototype I created, and if and when I make the next generation target, I'll implement even more features like a reaction timer, various sound effects when the target is hit, multiple targets, the list goes on and on. And if Laserlyte Company wants to use my ideas, please contact me. Thanks for watching.